Welcome to aminacademy.com. In chemistry, let us discuss about ions and ionic compounds. Before that, what is atoms and ions? Look at this figure. A neutral atom, when it loses of electron, it becomes positive ion. That's called cation. When neutral atom gains of electrons, that it becomes negative ion, that is anion. Atoms are neutral. They contain the same number of protons and electrons. By definition, an ion is an electrically charged particle produced by either removing electrons from a neutral atom to give a positive ion or adding electron to neutral atom to give a negative ion. When an ion is formed, the number of protons does not changes. Cation. An ion that has a positive charge. Anion. An ion that has a negative charge. Now let us discuss about chemical reactivity. The chemicals have the ability to react when exposed to other chemicals or certain physical conditions. The reactive properties of chemicals vary widely and they play a vital role in the production of many chemicals, materials, pharmaceutical and food products we use daily. When chemical reactions are not properly managed, they can have harmful effects or even catastrophic consequences such as toxic fumes, fires and explosions. These reactions may result in death and injury to people, damage to physical property and severe effects on the environment. So the chemical reaction should take care. That means when you produce the production of chemicals, you should take care about dangerous things. Next, noble gas. Now before that, we will discuss further about chemical reactivity. Some elements are highly reactive while others are not. For example, consider the difference between oxygen and neon. Notice that oxygen reacts readily with magnesium, but neon does not. Why it has happened? Why is oxygen so reactive while neon is not? How much an element reacts depends on the electron configuration of the atoms. For example, here we consider oxygen. That is, we use like O. That is, electronic configuration is 1s2, 2s2, 2p4. Here, notice that here 2p orbital, which can hold 6 electrons, but oxygen have only 4 electrons in outermost, that is in p orbital, have only 4 electrons. The electron configuration of neon look at here, neon Ne have 1s2, 2s2, 2p6. Here the p orbital fills all electrons, that is 6 electrons. So oxygen is more reactive, the neon is not reactive with some other elements. Next, noble gas are least reactive elements. Neon is a member of the noble gas because that outermost orbit filled full electrons, which are found in groups 18 of the periodic table. In group 18, there are noble gases is very less reactive. The noble gases show almost no chemical reactivity. Because of this, noble gases have a number of uses. Because of this, noble gases number of uses. For example, the tungsten filament bulb is filled with some other noble gases, argon like, because the tungsten filament with high temperature can react with oxygen, and the filament will damage very quickly. So we have to protect the reaction with oxygen to the tungsten filament. So we have to fill with argon, so it is not reactive with other elements easily, so that filament will last long. We know that neon is a member of noble gases, which are group 18 of the periodic table. The noble gases show almost no chemical reactivity. The other noble gases also have filled outer energy levels. This electron configuration can be written as ns square and np6, means out p orbital have 6 electrons. Next, alkali and halogens are the most reactive elements. Based on this octet rule, an atom whose outer s and p orbitals do not match the electron configuration of a noble gas will react to lose or gain electrons, so the outer orbitals will be full. This prediction holds true for alkaline metals, which are some of the most reactive elements. The halogens are very reactive as member of group 17. They have 7 electrons in their outer energy level. By gaining just 1 electron, the halogen will have the s and p configuration of a noble gas. For example, by gaining 1 electron, the chlorine electron configuration becomes chlorine is 1s2, 2s2, 2p6, 3s2, and it gains 1 electron. Chlorine's electron configuration becomes 3p6. So 2 plus 2 is 4, plus 6 10, and 2 plus 6 18. But chlorine have 17 electrons, but chlorine atom have 17 electrons, but it gain 1 electron to form a noble gas structure. That means chlorine is highly reactive, and gaining one electron to form a noble gas structure. Actually, last things is p5, 1 electron it gains, and it becomes electron outermost p orbital is 6 electrons. Alkali metals such as potassium react readily with a number of substances including water, like that is, alkali metals are highly reactive because it react with for example potassium, and react readily with a number of substances including water also. Next we will discuss about valence electron. Number of electrons in outermost orbit is called a valence electron of element. We may notice that the electron configuration of potassium after it loses 1 electron is the same as that of chlorine. That means potassium, if you lose 1 electron, it forms like loses 1 electron, and the same as the electronic configuration of chlorine after it gain 1 electron. Also, both configuration are the same as that of the noble gas organ. After reacting, both potassium and chlorine have become stable, that is potassium chloride. The atoms of many elements become stable by achieving the electron configurations of noble gases. That means after ionic compound created, that most of the elements forms a noble gas structure. Periodic table reveals an atoms and number of valence electrons also. Here, suppose for example, Mg, magnesium is, you can write, it becomes neon configuration with 3s2. Atoms gain or lose electrons to form a stable ions. When recall that potassium loses its one valence electron, so it will have the electron configuration of the noble gases. But why does not potassium atoms gain 7 more electrons to become stable instead? Because gaining 1 electron is easier than the gaining 7 electrons. The reason is the energy that is involved. Removing 1 electron requires far less energy than adding 7 more. Now look at here. Suppose potassium element gives potassium positive ion and losing 1 electron. Now the ion of the positive charge is called cation, losing 1 electron. Now therefore potassium positive ion can be written in electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. And argon 1s2, 2s2, 2p6, 3s2, 3p6. Like then an ion with a negative charge is called an anion. A chlorine anion has an electron configuration just like the noble gas of argon. Look here, chlorine negative ion, it become 1s2, 2s2, 2p6, 3s2, 3p6. In argon, the noble gas of electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Some stable ions do not have noble gas configuration. Some even it gain or lose electrons. Some stable ions do not have noble gas configuration. Most of the stable ions become noble gas configuration. Some of them is not. Next one, atoms of metals and non-metals elements form differently. Here, many atoms form stable ions that have noble gas configuration. It is important to remember that these elements do not actually become noble gases. Having identical electron configuration does not mean that a sodium cation is a neon atom. The sodium cation still has 11 protons and 12 neutrons, like a sodium atom that has not reacted to form an ion. But like a noble gas atoms, a sodium ion is very unlikely to gain or lose any more electrons. Here, next, atoms of metals and non-metals elements form differently. Nearly all metals form cations, as can be seen by examining their electron configuration. For example, consider the configuration of the group 2 metal magnesium. See here, suppose magnesium have electronic configuration 1s2, 2s2, 2p6, 3s2. To have a noble gas configuration, the atoms must either gain 6 electrons or lose 2. Losing 2 electrons requires less energy than gaining 6. Similar for all metals, the energy required to remove electrons from atoms to form ions with a noble gas configuration is always less than the energy required to add more electrons. As a result, the atoms of metals form cations. Now, further discussion we'll do in further videos. If you have done, please subscribe our YouTube channel.